Okay, I guess I'll get started. My name is Lydia, and this is the R4DS online learning community, the ggplot2 book club. Today I'm going to be going over chapter 15. I apologize, it says chapter 16. Little mishap with the placeholders. But yeah, so chapter 15 is scales and guides, and the learning objectives would be to illustrate that there is nothing preventing you from transforming other kinds of scales beyond continuous position scale, to show how concepts for position scales apply elsewhere, and to discuss the theory underpinning scales and guides. Okay, so theory of scales and guides. Each scale is a function from a region in data space, which is the domain of the scale, to a region in aesthetic space, the range of the scale. And the axis or legend is the inverse function known as the guide. And it allows you to convert visual properties back to data. So surprisingly, axes and legends are the same type of thing, but while they look very different, they have the same purpose, to allow you to read observations from the plot and map them back to the original values. And the commonalities between the two are illustrated below. So you have within axes where you would have the argument name, it would then be called, oh, I'm doing wrong. I think that was supposed to say, I have a feeling that was supposed to say legend. But yeah, argument name for an axis would be label, for a legend would be title. Argument, the breaks would be ticks and guidelines on an axis, and on a legend would be key. And then like the labels would be the tick labels, and for axes, and on a legend it would be the key label. And however, legends are more complicated than axes, and consequently, there are a number of topics that are specific to legends. For example, a legend can display multiple aesthetics, such as color and shape, from multiple layers, which we'll see in section 15.7.1. And the symbol displayed in a legend varies based on the geomes used in the layer, which we'll see in 15.8. And axes are always in the same place, where legends can appear in different places. So you need some global way of positioning them. And legends have more details that can be tweaked. And like, for example, should they be displayed vertically or horizontally? How many columns do you want? How big should the keys be? And this will be discussed in section 15.5. Okay, so we have scale specification. An important property of ggplot2 is the principle that every aesthetic is in your plot is associated with exactly one scale. For instance, when you write this, ggplot mpg aesthetic displacement on highway plus the geom point aesthetic color is equal to class. ggplot2 adds a default scale for each aesthetic used in the plot. Here we see like by default they add the scale x continuous and the scale y continuous and the scale color discrete. And the choice of default scale depends on the aesthetic and the variable type. And in this example, highway is continuous variable mapped to the y aesthetic, so that the default scale is a scale y continuous. Similarly, class is discrete, so when mapped to the color aesthetic, the default scale becomes scale color discrete. And specifying these defaults would be tedious, so ggplot does it for you. But if you want to override the defaults, you'll need to add the scales yourself, like this. Oh, hi Ken. Okay. So yeah, and in the book they didn't actually show you the graphs. It was this section, they just kind of showed you the code. But yeah, so you can add the scale yourself. So for example, here, they changed the name of the title for the axes, where the title for the x-axis was a really awesome x-axis label, and for the y, they changed it to an amazingly great y-axis label. I can actually, I can show you where they did the, yeah. So actually, yeah, that's the original plot. And then when they added these, it's the exact same plot. And then here, when they added the labels, it adds the labels on the axes. Okay. And okay. So in practice, we would typically use labs for this, discussed in section 8.1, but it is conceptually helpful to understand that the axis labels and legend titles are both examples of scale names, in see section 15.2. The use of the plus to add scales to a plot is a little misleading because if you supply two scales for the same aesthetic, the last scale takes precedence. And in other words, when you plus a scale, you're not actually adding it to the plot, but overriding the existing scale. And this means that the following two specifications are equivalent. So here it's saying that this part, the one I've highlighted, where it has both the scale x continuous, where name is equal to label 1, and then again they added scale x continuous, name is equal to label 2, because when you add a second plus, the first one that says label 1 is overridden by the label 2. So these two plots will be exactly the same. Let me see. Yeah, and it brings up that warning that the scale for x is already present and it would be replaced. So there's this one where it says label 2, that should be the first one. And then the second one where it also says label 2. And then note the message when you add multiple scales for the same aesthetic, which makes it harder to accidentally overwrite an existing scale. And if you see this in your own code, you should make sure that you're only adding one scale to each aesthetic. So this was like what they meant by that, the warning message you get. And if you're making small tweaks to the scales, you might continue to use the default scales, supplying a few extra arguments. And if you want to make more radical changes, you will override the default scales with alternatives. So here, the alternatives they added were scale x square root and then scale color brewer. And here the scale x square root changes this of the x-axis scale, and the scale color brewer does the same for the color scale. So we see it here. So here they added the scale, scale x square root and the scale color brewer. So at least with the color brewer, you see how it changed. Previously the all the points were black, but now they added the blue, like the gradient blue points. And I was actually a bit confused with the scale x square root, because to me it didn't actually look like it changed the scale at all. But maybe I'm not quite interpreting it right.
It changes the spacing. The numbering doesn't change, but the spacing changes. If you look, the distance between 2 and 3 and the distance between 6 and 7 are not the same.
Oh, okay. Now I see what you mean. Okay.
It's similar to a log scale that would change the spacing, but it doesn't. But it keeps the numbering on of the original aesthetic.
Oh, okay. Yeah, because I was looking at it, I'm like, okay, now it makes more sense. Yeah, because it lessens the size. Okay, thank you. Yeah, because I kept looking at it, I'm like, I don't know what's changed. Okay. Okay, so we have 15.1.2, which is naming scheme. And the scale functions intended for users all follow a common naming scheme. And you've probably already figured out the scheme, but to be concrete, it's made up of 3 pieces separated by I believe it's called like an underscore. So the first one is scale, and then the name of the primary aesthetic, such as color, shape, or X, and then the name of the scale, which would be like, for example, continuous, discrete, or brewer. And the structure is often helpful, but can sometimes be ambiguous. For example, while the name scale color continuous clearly refers to the color scale associated with a continuous variable, it is less obvious that color scale distiller is simply a different method for creating color scales for continuous variables. Now 15.13, 15.13, fundamental scale types. All scale functions in ggplot2 belong to one of three fundamental types: continuous scales, discrete scales, and bin scales. And each fundamental type is handled by one of the three scale constructor functions: continuous scale, discrete scale, and bin scale. And although you should never need to call these constructor functions, they provide the organizing structure for scales, and it is useful to know about them. So next we have 15.2. In my book, this one and the next one, they didn't really have much, I think, because the book is still kind of under construction. So this one said extend discussion of labs in section 8.1. And then the next one, which was 15.3 scale breaks, it just said discussion of what unifies the concept of breaks across continuous, discrete, and bin scales. And there are specific data values at which the guide needs to display something, include additional detail about break functions. So next we have 15.4, which was scales limits. And in section 15.1, introduce the concept that a scale defines a mapping from the data space to the aesthetic space. And scale limits are an extension of this idea. They dictate the region of the data space for which the mapping is defined. And at a theoretical level, this region is defined differently depending on the fundamental scale type. And so for continuous and bin scales, the data space is inherently continuous and one-dimensional, so the limits can be specified by two endpoints. And for discrete scales, however, the data space is unstructured and consists of only one set of categories. As such, the limits for a discrete scale can only be specified by enumerating the set of categories over which the mapping is defined. The toolbox chapters, what they were calling the toolbox chapters, I believe chapters 10 through 12. The toolbox chapters outline the common practicables for specifying the limits. For position scales, the limits are used to set the endpoints of the axis, for example, and this leads naturally to the question of what ggplot2 should do if the dataset contains out-of-bounds values that fall outside the limits. And the default behavior in ggplot2 is convert out-of-bounds value to NA. The logic for this begin if a data value is not part of the mapped region, and it should be treated as missing. And this can occasionally lead to unexpected behavior, as illustrated in section 10.1.2. And you could override this default by setting OOB, which is out of bounds, argument of the scale function that is applied to all observations outside the scale limits. And the default is scales OOB sensor, which replaces any value outside the limits with NA. And another option is scales OOB squish, which squishes all values into the range. An example using a fill scale is shown below. So this one, they said DF is equal to data frame, X is 1 to 6, Y is 8 to 13. Base ggplot2 DF, aesthetic X and Y, plus GM color, aesthetic fill is equal to X, making a bar chart. GM V line, the X-intercept is 3.5 and the color is red for visual clarity. So here, yeah, you see they made the bar chart with the fill color based on the X values, and they put the vertical line here at 3.5 and in red. And then this one, let's see, this one where they set the limit to 1, 2, 3. So then there's the cutoff. I think now these become like the out of bound values, and which make them kind of NAs. So the fill color is just gray. And then this one where they did where they added the OOB is equal to scale squish. So now even though these are out of bound for the range they had originally set, the 1 to 3, it takes that last color and kind of adds that color. I think, let me see, that's kind of what they say. Yeah, so the first one, the fill colors are shown, ranging from dark blue to light blue. And then the second plot, the middle, for the fill aesthetics, they're reduced so that the values of the three rightmost bars are replaced with NA and are mapped to the grayscale. And in some cases, this is a desired behavior, but often is not. And like this last chart, it's modified so that the OOB function appropriately. Again, adding like the blue color rather than having it gray. Okay.
I have a quick question on that one, if you'll go back.
Mhm.
My guess is if you're, let's say, if you can just go up to the one previous, the view previous, that one right there with the grid. So let's say that you really only wanted to highlight the first column and the third, and you wanted all the rest of those to be gray. My guess is that you couldn't do it this way because the limits are more of like a discrete. So you really only get the starting point and the ending point, and you can't like skip something in the middle. Does that sound right?
I'm guessing so.
Yeah, because you're setting a limit, like an upper limit and a lower limit, not like specifically picking just.
Like, yeah.
Okay.
I don't. Yeah. Let me see if I can change it.
You'll just get one and two.
Yeah, so this is the last one. Yeah, so it made it, but I left the vertical line where it was at 3.
Yeah.
So yeah, so now you only get 1 and 2, and then all the rest are grayed out. And then in this one with the squish, where it was like you still only getting 1 and 2, and then the rest of them keep the color from 2. Yeah, so I'm not sure if it's possible to change it. So
I think you just have to take a different approach.
yeah.
Limits isn't going to do it.
Yeah.
I think you might have to change the X value to a factor, and then you could use limits to pick the specific values you want to show.
Makes sense. Okay, just curious. Thank you.
Okay, great. Thank you, Ken. Let me just change that now. Okay. Okay, so we have 15.5, which is scale guides. And scale guides are more complex than scale names, where the name argument and labs or labels take text as input. The guide argument and guide require a guide object created by a guide function, such as guide color bar and guide legend. And these arguments to these functions offer additional fine control over the guide. The table below summarizes the default guide functions associated with the different scale types. So like for scale types, continuous scales for color or fill aesthetics, the default guide type is color bar. And for bin scales for color fill aesthetics, it's color steps. And for position scales, whether continuous, bin, and discrete, it's access. And discrete scales, except for position scales, it's a legend. And then, so that makes sense. Okay. Yeah. And then bin scales, except position, color, and fill scales, it's bins. So each of these guide types has appeared earlier in the toolbox. For example, guide color bar was discussed in section 11.2.5, and guide color steps was discussed in section 11.4.2. Guide access was discussed in section 10.3.2. Guide legend was discussed in 11.3.6, and guide bins was discussed in section 12.1.2. And in addition to the functionality discussed in those sections, the guide functions have many arguments that are equivalent to theme settings like text color, size, font, etc., but only applied to a single guide. And for more information about these settings, see chapter 18. Okay, so we have scale transformations. And then, so the most common use for scale transformations is to adjust a continuous position scale as discussed in section 10.1.7 And however, they can sometimes be helpful when applied to other aesthetics. Often this is purely a matter of visual emphasis. For example, this is for the Old Faithful density plot shown below, and the linearly mapped scale to the left, or rather the first one, yes, the first one, makes it easy to see the peaks of the distribution, whereas the transformed representation on the bottom makes it easier to see the regions of non-negligible density around the peaks. So yeah, I think you guys remember the Old Faithful was regarding the Old Faithful geyser and the eruptions. So yes, they have base, ggplot, Faithful D, aesthetics, weighting, and eruptions, and they added the raster with aesthetic flow is equal to density, scale X continuous, and scale Y continuous. So this is the base, and then for this one, the scale flow continuous, they did the transformation equal to square root. So like for me, this was a bit more conceptually hard to understand, but what I did notice is like you see like more, like there's more light blue on this one versus the other one where it was less light blue. And I think that's they were mentioning about it makes it easier to see the regions of non-negligible density. Yeah, if anyone has any more insight onto this part, feel free to chime in for sure. Yeah, so then also there's transforming size aesthetics is also possible. So they have this data frame and the base. Let me see. So this is like the original, and then they did the transformation where they reversed the size. I think you kind of see that the points that were big are kind of now small. This kind of seems what they did. And yeah, you can see it on their legend. Oops. Yeah, you can see it on their legend where 5 is now the biggest, 10, and then 20 is the smallest. And then up here where 5 was the smallest, and then 20 is the biggest. So in the plot on the top, the Z value is naturally interpreted as a weight, and if each dot corresponds to a group, the Z value might be the size of the group. And in the plot on this bottom plot, the size scale is reversed, and the Z is more naturally interpreted as a distance measure. Distant entities are scaled to appear smaller in the plot. Okay, and then so 15.7, legend merging and splitting. There is always a one-to-one correspondence between position scales and axes, but the connection between non-position scales and legend is more complex. One legend may need to draw symbols from multiple layers, known as merging, or one aesthetic may need multiple legends, known as splitting. Okay, so merging legends. Merging legends occurs quite frequently when using ggplot2. For example, if you map color to both points and lines, the keys will show both points and lines. And if you mapped fill color, you get a rectangle. Note the way the legend varies in the plots below. Let's see. But by default, a layer will only appear if the corresponding aesthetic is mapped. I should have the book open. Sorry about this. I think I left out. Okay, so yeah, these, okay, those are what he's talking about. Note the legend varies in the plots below. Okay, so these are the plots. So here where there's just the dots, and then on these ones, the legends are like a dot and a line. And then on these ones, the legends are like the squares with the colors. Yeah, I wasn't sure how to add those, or rather I had to get the code from somewhere else, but I can go back and add it in. And by default, a layer will only appear if the corresponding aesthetic is mapped to a variable with AES. And you can override whether or not a layer appears in the legend with show legend false to prevent a layer from ever appearing in the legend. True forces it to appear when it otherwise wouldn't, and using true can be helpful in conjunction with the following trick to make points stand out. Okay, so then this one they use the toy data set, aesthetic up and up, GM point size equal 4, color is equal to gray 20, GM point aesthetic color is equal to TXT, I'm assuming that's text and size is equal to 2. And then, so this is the, like the default legend. And then with this one, where they point, where they put within GM point, they put show.legend is equal to true. You see that it changes the legend to have the dark circle around the colors versus in this one where it didn't have that. And then ggplot tries to use the fewest number of legends to accurately convey the aesthetics used in the plot. And it does this by combining legends where the same variable is mapped to different aesthetics. And the figures below shows how this works for points. And if both color and shape are mapped to the same variable, then only a single legend is necessary. Okay. So this one, again, you're looking at the legend where the dots, it shows like the dots just based on the color, or rather the points, just based on the color. And this one where, yeah, so this one where it's GM point aesthetic color is equal to TXT. And then this one, GM point aesthetic shape with a TXT. So you see it changed the shape of it within the legend. And then this one, GM point aesthetic shape is equal to TXT and color is also equal to TXT. So they changed both the color and the shape of them. And then, so in order for legends to be merged, they must have the same name. So if you change the name of one of the scales, you'll need to change it for all of them. And one way to do this is by using Labe's helper function. So we have, okay. So we have this one where, I think this was like the last one they showed, where scale x continuous null breaks is equal to null. So you have this space, and then with the labs, it shows the, oh wait, I'm skipping. With the labs, it shows a split legend where you see both the color, the color label, and then also the shape as well, where A is both a circle and it's red, B is a triangle and it's green, C is like this cyan color and it's a square, and then D is like the plus sign and it's purple. And then this one is like merge where like you have both sets of those information into that one legend versus splitting the legend. Yeah. Okay, so then, okay, so 15.7.2, oops, sorry. Splitting legends. Splitting a legend is much less common data visualization tasks. In general, it's not advisable to map one aesthetic, such as color, to multiple variables, and so by default, ggplot2 does not allow you to split the color aesthetic into multiple scales with separate legends. Nevertheless, there are exceptions to this general rule, and it is possible to override this behavior using the ggNewScale package. So ggNewScale, new scale color command acts as an instruction to ggplot2 to initialize a new color scale. Scale and guide commands that appear above the new scale color command will be applied to the first scale color, and commands that appear below are applied to the second color. Okay. And to illustrate this plot, below, the first plot uses geom_point to display a large marker for each vehicle make in the MPG data with a single color scale that maps to the year. And below that, a second geom_point layer is overlaid on the plot using small markers, and this layer is associated with a different color scale used to indicate whether the vehicle has a 4-cylinder engine. So you see this first one, this is kind of like our base plot. And then here's the second plot where they overlaid the second legend where it's like the gray dot is false as far as whether or not it has a 4-cylinder, and then the black dot is true, that it has a 4-cylinder. And then we have the green where it's, we have the year where green is 1999 and the orange salmon color is like 2008. So you see like a lot of these, you have like 1999 that is 4-cylinder, and then also 2008 that is 4-cylinder, and then you have over here a lot of them where they're not 4-cylinder, and again the varying colors based on the year. And let me look at the code. Yeah, so I think this is where they have the color scale manual with the 4-cylinder, and the values are C, which is I guess the gray 60 equals false, and then the black is true. Based on I think that was the main difference. And then so for additional details, including functions that apply to other scale types, are available on the package website for GG New Scale. Oh, that didn't. Oh, sorry about that. Oh, okay. I'm gonna stop doing that. It's like not working. Okay. So then we have 15.8, which is legend key glyphs, and in most cases, the default glyphs shown in the legend key will be the appropriate to the layer and the aesthetic. And should you need to override this behavior, the key glyph argument can be used to associate a particular layer with a different kind of glyph. For example, here we have the space plot where it's ggplot economics and the aesthetic is date and PS avert, and color is equal to savings. And then we added a geom line here. And then like for the glyph here, it's kind of like the straight reddish line for savings. But then here where they added the key glyph is equal to time series, it changed like the picture in here where it's kind of like it looks like it's time versus like a straight line for savings. And so more precisely, each geom is associated with a function such as draw key path, draw key box plot, or draw key, oh, I think I put that down, draw key path, which is responsible for drawing the key when the legend is created. And you can pass the desired key drawing function directly. For example, base plus geom line key glyph is equal to draw key time series would also produce this plot shown. So yeah, so yeah, here I think what the difference in those two is where they say key glyph is equal to time series within the quote versus key glyph is equal to draw key time series. Those two things would create the same plot where you have this, I guess it's called the glyph within the legend. And so that is all I have for today. I want to see if I can open that page. Oh, actually, I may do it from the actual. Okay, so yeah, this brings you to the GitHub repo for that the package that was mentioned in the book, GG New Scale. So GG New Scale tries to make it painless to use multiple scales in ggplot2. And although originally intended to use the color and fill, it should work with aesthetic and shape. Oh, any aesthetic such as shape, line type, and the rest. And it's, well, experimental and use at your own risk. So yeah, so this is, oh, that's pretty. Something else to look into if you wanted to find out more about this. Yeah, so that is all I have for today. I guess if anyone has any questions or comments.
Looking at the different key glyphs, there's a draw key AB line. I'm wondering what does that do? But there's no example, so I don't know. There's some playing around, I guess.
Yeah, this is a pretty interesting chapter. It's a very interesting chapter. I feel like I learned a lot. Yeah, and it's pretty interesting. Okay, if there's something else, I'll stop sharing. Yeah. Okay, so yeah, that was my presentation for today.
Thank you. There's a lot of interesting tweaks that you can do with the scales and legends.
Yeah, it's pretty cool. Yeah. Now I'm really happy that I joined this book club because like I'm learning so much. I mean, I haven't gotten to play around with everything, but like I feel like when I do start doing like more data visualization, I'm gonna have a better idea of all the different things I can like play around with to get like the plot I'd want. Pretty cool. Yeah, so I guess I don't know if we adjourn or early or if anyone had anything else to discuss.
My side, thanks so much for all that information. I just keep, every time something comes up, I keep thinking, wow, like R can do that. R can do that. R can do that.
Right. Right. Yeah. Yeah. Now I feel a bit more confident about like trying out a Tidy Tuesday because I haven't done one yet. And actually one of the clubs at my school, the data science club, they're gonna start like helping people do like get into doing Tidy Tuesday. I think I'm slowly getting pumped up to try it out. Yeah.
I found some examples. I'll paste.
Oh. Okay.
I guess the AB line is just the regular diagonal line. Doesn't seem to be different from just the line.
Yeah.
Lydia, do you mind going
it's-
to, sorry, can't
It's
forgive
at
me.
an angle instead of, I guess if you just do a line, normally it's horizontal, is that right?
Mhm. Well, this one, like on the thing you sent, the draw key AB line, it's actually on mine, it looks diagonal rather
Yeah,
than,
and the
yeah,
regular draw key
the
line
regular
is
ones,
horizontal, so it's,
yeah,
that's the difference.
yeah. It's pretty cool.
Lydia, I was going to ask, do you mind showing the paragraph 1571, the merging legends section again? I wanted to ask a question to June and Kent and
Okay.
see what their take would be on the comment.
You said 15.7.1?
Yes.
Mhm.
So I had a question for the team, and I'm looking at this particular graph with the circle and then the line around the circle as being the same color. What draws me to this conclusion is the differences between fill and stroke when it comes to, I guess, objects, images, when you're drawing it in a vector space. What I'm trying to ask, or what I'm trying to comply or figure out, the differences between the aesthetic of color equals text. What is creating the outer boundary, I guess, or what is creating the stroke around that circle?
It's the first geom point. He's drawing them with size 4 and colored gray, and then with size 2 colored by text. So it's actually two dots, one on top of another,
Okay.
with a larger one behind.
That makes sense. So your 4 and 2 are actually the differences between, and because they're overlaid with each other, that's what
Right.
provides what appears to be a fill and stroke concept.
Yeah, which you actually can do with some of the
Okay.
point shapes as well. So maybe that's could be causing some confusion. There are some shapes that have both a boundary and a color and a fill, but that's not how he did this here.
Yeah.
So like if you put the size up to 6, for example, in the first one, you would get a larger boundary. Whereas if you're using the shape aesthetics, you wouldn't be able to have, different, you wouldn't be able to make the boundary big.
Yeah, Lydia, I don't know if you have that code snippet or not.
Yeah, I do. I'm just forgetting where it was. That was in breaks, or what part was that? 7?
Yeah, it was in the merging legends section, I think.
Merging and splitting is the subheading.
Okay. Original splitting. Okay, so I think we said
Yeah, make
change
that 6,
to 6.
and you'll see that it,
Not sure why that didn't.
yeah, where's it putting your output?
Yeah, where's
Is it putting it over?
with it?
Okay.
Yeah.
So what we're trying to do, Kent, is obviously it's going to be a larger circle with a smaller fill in the center of it by changing that
Yeah,
from.
well, the fill size will be the same, but
Okay.
the border should be bigger now.
Oh, it didn't.
There it
Oh,
is.
this
There,
one.
yep.
Okay, yeah. Okay.
Okay. That makes a lot of sense. I hadn't considered it to be layers. That makes sense.
Yeah. Okay, cool. Oh, let's change that back. Yeah, that's pretty cool. I'm getting much more confident with playing around with it. I feel like in my first few presentations, I'm like, I'm not gonna change any code. I'm gonna mess it up somehow. Yeah.
All right. So I guess we'll see you next week.
Sounds good.
Good, thank you.
Thanks
Thanks,
again.
Thank you. Okay.
Thank
Bye.
you. Bye.